All right, so let's get right into it. Today we're doing something a little different. We're not talking about a new theory or some wild hypothesis. We're going to demonstrate a new grammar. Yeah, a grammar. A whole new way to read the data we get from the cosmos, a way to see the language we thought we knew in a completely different light.
You've definitely seen this picture before, right? It's iconic, the supermassive black hole at the heart of galaxy M87. We look at it, we see that glowing donut, that dark spot in the middle, and we think we know the story. It's this cosmic monster, a point of no return.
But what if that whole story is wrong? I mean, what if nothing has collapsed at all? What if what we're actually looking at isn't a breakdown of physics, but a signature of perfect, sustained coherence? It's a pretty radical idea, and that's what we're diving into.
Okay, so to really get this new perspective, we've got to start with the picture we already have. We need to look at what we think we know and admit that, well, there are some pretty big flaws in the frame.
And let's be clear, nobody's arguing with the actual observations. The data is solid. We see that incredibly bright, sharp ring. We see one of the most powerful jets in the entire universe blasting out of there. We see light getting bent all over the place. And those magnetic fields, they're super organized, not just some random mess. These are the facts on the table.
So yeah, the problem isn't the data, it's the story we're telling about it. The standard black hole model, when you try to make it fit all of these observations at once, it starts to run into some serious problems. The source material calls them non-closures, which is a fancy way of saying the math just doesn't add up. I mean, just think about it for a second. The whole idea of a singularity, it's literally a point where our understanding of physics just stops, it breaks. Then you've got the information paradox, which basically puts two of our biggest theories, quantum mechanics and general relativity, into a fight to the death. Even our own galaxy's core, Sagittarius A star, doesn't really fit the standard models. And maybe the biggest thing is, there's no single unified explanation that can spit out the ring, the jet, and the magnetic fields all from one starting point. And this right here is the perfect example of what I'm talking about. The core of M87R is spinning backwards against its accretion disk. Now, according to the standard model, that should make the jet weaker. But what do we see? One of the most powerful jets in the known universe. The model predicts the exact opposite of what we're observing. That's a huge problem.
So here's the key takeaway. The source material is arguing that these aren't just little mysteries that we'll figure out later on. No, these are fundamental contradictions. They're big red flags suggesting that maybe the entire frame we're using to look at this thing is just wrong. All right, so let's get to the solution that's being proposed here. And it really requires a huge shift in thinking. Instead of trying to find a cosmic noun, an object like a black hole, this approach asks us to trace a cosmic verb. We're looking for a process, a field that's organizing itself under insane pressure.
The whole idea is simple. Field first. The electromagnetic field is the star of the show here. We're not watching matter fall into nothingness. We're watching a field maintain its own coherence. That ring, that jet, that shadow in the middle, they're all just different expressions of this one field doing its thing.
Okay, so how do we read this field? This is the tool we're given, the phase cell map. Don't think of it as a map, really. It's more like a Rosetta Stone for field dynamics. It's the grammar. The columns, that's the energy of the field, electric, field, and magnetic. And the rows, that's the function. Is the energy pushing out, staying balanced, or pulling in? Each of these 9 cells describes a totally unique state. These aren't just random labels. They're the fundamental words in this whole new cosmic language.
So let's put it to the test. Let's actually use this grammar to read what's happening in M87 star. The claim here is that we can trace one single complete cycle, like one breath of the field, right through this grid, and it's going to map perfectly onto everything we actually see.
All right, here we go. The cycle kicks off with this big outward formative push. It starts at the bottom with a spark of pure outward energy. That's the jet. That energy then creates a scaffold for it to build on. That's the organized flow of matter around it. And finally, the whole process crests as that stable, glowing photon ring we see in the picture. You see? Jet, flow, ring. One single, coherent action. Then, the cycle hits the brakes and reverses into that middle row, the modulation row. It hits cell 96, the torque hinge, which lines up perfectly with the gravitational lensing we observe. Then, it passes right through that all-important center, 66, we'll come back to that in a sec, and it finishes with this focused indraw, a magnetic pole that describes that organized, spiraling polarization pattern that we see. It all just fits.
Okay, so let's talk about that center cell, 66. This is absolutely crucial.
In this new grammar, that dark spot in the middle of M87's star is not a void. It's not an absence. It's the coherence anchor, the organizing hub of the whole system. It's a point of perfect dynamic stillness, where the push-out and the pull-in are so perfectly balanced that nothing escapes. It's not a place where information dies. It's the point of total coherence.
And then the cycle reverses one last time, into the top row, the containing arc. The field moves through deep compression and gestation saturation. Basically, it's storing and integrating energy. And this all culminates in cell 93, the respark. This is the moment all that compressed coherence is released right back up the axis, reigniting the jet and starting the whole beautiful cycle all over again.
Now, this is where this whole idea of a grammar gets really, really powerful. Because the argument is this isn't just about the centers of galaxies. This exact same pattern, a field holding its coherence under pressure, apparently shows up at every single scale in the universe.
It's called the scaling law, and the idea is pretty straightforward. Once a system hits this point of coherent balance, it becomes the stable foundation for the next level of structure to build on. Let's look at a few examples.
Let's start super small, down on the scale of nanometers, inside our own bodies. The little voltage gates in our cells, they operate at about 70 millivolts. That's not a random number. It's the point of perfect balance, the coherence condition, between the pressure of the ions and the cell membrane.
Okay, now let's zoom way out, to hundreds of kilometers up, the edge of Earth's ionosphere, right where our atmosphere meets space. That boundary is set by a potential of about ½ a volt. It's the same principle. It's the balance point where the push-out and the pull-in meet.
And now let's go as big as you can imagine. Those vast cosmic filaments that make up the skeleton of the universe, they stretch and stretch until their own internal tension perfectly balances the pressure of the space around them. From a tiny cell to the entire cosmos, this grammar seems to hold. So at the end of the day, we're left with a really critical choice, a huge distinction. The standard model gives us an object with a horizon where physics breaks and information is lost forever. This grammar, it gives us a tension line intersection, a point of inversion where information is constantly being re-encoded and coherence always holds.
And that really leaves us with one final, pretty mind-bending thought. What if we've been looking at the center of the galaxy all wrong? What if we've been mistaking a point of perfect absolute organization for a point of total collapse? What if the heart of the galaxy isn't where things end, but where the whole cosmic cycle begins again?